Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's deep dive into Crossplane. Let's try to understand what is Crossplane, why is it being considered one of the better alternatives to Terraform. Let's also understand if it is true, is it genuinely going to replace Terraform in the future? Then let's understand what are some drawbacks of Terraform, how is Crossplane designed to address these challenges. We'll also look at the installation. We will do a short demo of Crossplane. But most importantly, towards the end of this video, I'll share the pros and cons of both Crossplane and Terraform and give you a very clear picture which IAC tool should you use in 2026 and going forward. So this is going to be a very informative video. Make sure you watch the video till the end. And just like many tutorials on this channel, even for this tutorial, I have a GitHub repository. You can find that repository link in the description as well as the pinned comment. So that after watching the video, you can also go ahead and try Crossplane at your end. Let's get started. Let's start with state file management. So basically, when you look at Terraform, state file is the heart of Terraform. It is the single source of truth. So whatever you create with Terraform, Terraform keeps a track of it. It keeps a note of it in a state file called terraform.tf state file. Now this is just like a plain file where Terraform records every single information. Now the problem is that this file cannot be lost. If this file is lost, all the Terraform's memory is lost. Terraform cannot recreate the resources for you. On top of that, because this file is very sensitive, you cannot store the file in a Git repository. It can have sensitive information. It can have information of your resources metadata. So you need to store this in a remote backend, something like an S3 bucket or equivalent in other cloud platforms. You also have to make sure the state file is logged. Let's say two DevOps engineers or two developers are working on Terraform. They are trying to apply the Terraform configuration. Now state file cannot take or it cannot be updated for two different actions. So there is a possibility your state file can be corrupted. And this is one of the common things that DevOps engineer sees. Now, because of all of these reasons, Terraform state file management is complex. Now, I'm not saying this is impossible, but a lot of DevOps engineers find the state file management with Terraform is complex. Then the next thing, literally nightmare for DevOps engineers, is the drift detection problem with Terraform. So when you apply Terraform configuration, Terraform talks to the cloud provider APIs and it creates resources on the cloud provider. It can be AWS, Azure, GCP, or hundreds of providers that Terraform supports. Now this is good thing, but if someone goes to those cloud providers, let's say a DevOps engineer during production critical time, or a developer who has access to the cloud platform, goes to the cloud and manually updates the configuration, Terraform cannot detect it automatically. This problem is called as drift detection problem. Let me take a simple example. Let's say DevOps engineer creates an S3 bucket with version control enabled or with bucket encryption enabled. Now, some developer who has access to the AWS cloud platform or maybe DevOps engineer during the production critical time does not have enough time, goes to the cloud platform and updates the S3 bucket configuration. Now, Terraform cannot automatically detect it. It still thinks the configuration that it created is the source of truth or is the same configuration that is available on the cloud platform. But that is not the reality. Now, DevOps engineers will only come to know about it when they run Terraform plan. Now, they might run Terraform plan 7 days later, or in some projects, they might run Terraform plan 10 days later. For all these 7 days or 10 days, the cloud provider configuration is messed up and no one actually knows about it. So this is a major challenge and some of these actions can cause severe damage to the organization. Fine. Now third and the final one. This is not very serious, but still some DevOps engineers find learning HCL little difficult. So basically Terraform follows HashiCorp configuration language. Already DevOps engineers work on shell scripting, Python, YAML, JSON. Now this is another thing that they have to learn if they're working with Terraform, HashiCorp configuration language. So these are the three major challenges. Now let's try to understand how Crossplane address these challenges. So Crossplane is basically built to address the same challenges. What Crossplane does, it makes use of Kubernetes as a control plane. So basically, you install Crossplane in a Kubernetes cluster and it operates within the Kubernetes cluster. What advantages does it get by using Kubernetes as a control plane? If you have worked with Kubernetes, you know what Kubernetes is famous for is the Kubernetes reconcilers. Let's say you are working with a Kubernetes pod. You create a Kubernetes pod using deployment. So even if accidentally someone deletes a pod, deployment using the replica set controller can recreate the pod. The same concept. Now Crossplane is installed within a Kubernetes cluster. So if someone creates a resource using Crossplane, it creates a resource on the AWS, Azure, or any cloud platform, and it keeps the information within a Kubernetes reconciler. Now, the responsibility of this reconciler is to continuously watch the resource that it created on the cloud platform. Let's say using Crossplane, you create an S3 bucket. The information is with the Crossplane Kubernetes reconciler. If someone goes to AWS, manually updates the S3 bucket configuration, this reconciler automatically identifies the change because it is always comparing and it puts the S3 bucket in the previous state. Even before someone identifies it, like it might be 2 a.m. in the night, no DevOps engineer is active, but still Crossplane controller, because it is on Kubernetes, it is continuously watching the state of your AWS cloud platform and the state within the Kubernetes cluster. If there is any drift, it automatically patches the drift and brings the cloud platform resource to the previous state. And you don't have to manage the state file at all. In fact, in Crossplane, there is no concept of state file. Everything is within the Kubernetes, right? Just imagine replica set controller, the same concept. What replica set controller does, it continuously watches the state of a pod. If someone makes change to the pod resource, like let's say someone deletes a pod, replica set controller recreates the pod. Or if someone modifies the pod, replica set controller brings the pod to the previous state. Same concept Crossplane is using for infrastructure management, right? Let me explain this one more time for people who are new. So Crossplane makes use of Kubernetes as control plane. You don't have to install Crossplane on your local machine. You just have to put it in a Kubernetes cluster, maybe in your dev, staging, or prod cluster, wherever you are managing the infrastructure. Then Crossplane, DevOps engineer provides a YAML manifest to create S3 and S3 bucket. Crossplane creates an S3 bucket on AWS cloud platform, and it remembers that information in a Kubernetes reconciler. Kubernetes reconcilers are known for comparing the state on timely basis. They compare the state within the Kubernetes cluster, the information of S3 bucket that is provided to it, with the S3 bucket that is created on the cloud platform. If someone makes a manual change to the S3 bucket, reconciler brings the S3 bucket to the previous state. That's why with Crossplane, there is no state file management that is involved, and drift detection is completely automatic. Now you might say, what about HCL files? Of course, it's not needed because Kubernetes is a control plane. DevOps engineer provide Crossplane manifest as a YAML manifest. So it does not use HCL or any different scripting language or manifest language. It makes use of the YAML. So this is how the three problems with Terraform is addressed by Crossplane: state file management, drift detection, and the learning of any new configuration language. It makes use of YAML. To be even clear, let's look at both the implementations side by side. Let's say DevOps engineer working with Terraform, how the DevOps engineer workflow would look like. If a DevOps engineer is working with Crossplane, how their workflow would look like. Simple. If they're using Terraform, DevOps engineer submits a HCL file, basically creates a HCL file, by looking at Terraform documentation, maybe to create an EC2 instance. This resource is given to Terraform. Terraform is installed on the local machine or maybe on a virtual server. While creating the resource, Terraform makes an API call with AWS and the resource is created on AWS. While creating this resource, Terraform keeps the track of this information in a TF state file. That is the Terraform state file. This can be local, this can be in a remote backend, or this can be in any sensitive location. So this is why there is state file management involved and no drift detection that is possible. Now on the other side, if a DevOps engineer is using Crossplane, DevOps engineer submits a YAML resource, not HCL. By looking at the Crossplane documentation, they would create a YAML file, maybe for EC2 instance creation. This YAML file is given to the Crossplane controller that is installed within a Kubernetes cluster. Maybe DevOps engineer installs this controller using Helm, which is what we are going to do in a couple of minutes. Now this Crossplane controller creates an API call with AWS. This is same like Terraform and resource is created on the AWS platform. But while creating the resource, it does not create any state file. It keeps the information in a reconciler. This is within its Go implementation, the Go language implementation. You don't have to worry about it. So the moment someone makes change to the AWS resource, reconciler comes into picture and it takes care of the drift. This is the implementation side by side. Perfect. Now that this is clear, let's go ahead and learn how to install Crossplane. Once again, this information is available in the GitHub repository in the description as well as the pinned comment. First of all, you need a Kubernetes cluster. As we learned, Crossplane is installed on Kubernetes. It's make use of Kubernetes as a control plane. Let's create one. So I have kind on my local. I'll create a kind cluster. Kind create cluster. Let me call this as demo Crossplane cluster. We will have this very fast. Once we have this cluster running, then we will make use of a Helm command. Helm is very easy, right? With Helm, we can create the Crossplane controller in just one command. First, we will add the Crossplane Helm repository. Helm repo add Crossplane stable. So this will add the repository. If you already have the repository, you can just run Helm repo update so that you can install the latest version of Crossplane. Perfect. Now let's install. Now that we have the repo, this is the command. Helm upgrade -- install Crossplane. From the chat that we just installed, within the namespace Crossplane system. If this namespace does not exist on the kind cluster, which does not exist at this point, create the namespace. This will take 1 to 2 minutes. You can verify by just running kubectl get pods -n crossplane system followed by -w. Just watch the pods. If both the pods are in the running state, then you can go ahead. Cool. In my case, both of the pods are running. So my Crossplane system is installed. Now I already have AWS. So I have an account with AWS. Let's try to create an S3 bucket in this AWS account using Crossplane. But for that, we need to follow one more prerequisite. We need AWS credentials, right? So we will get those credentials. Basically, just like Terraform, you can head to the security credentials. Scroll down, you will find the access keys. Click on create access key. If you are using root user, you have to be little careful. So this is my access key and this is my secret access key. Just take a note of this access key and the secret access key. Nice. So now we are all set. Let's go back to our Kubernetes cluster. We will start with setting up a file called provider file. Same like Terraform, because Crossplane has to talk to AWS again using the API call itself. So we have to set up a provider configuration so that Crossplane understands to which cloud provider it has to make an API call. Let's call this provider aws.yaml. So this is in the YAML format. And in the GitHub repository, I have the configuration. You can just copy paste it. Save the file. So what is it saying? The provider for AWS. This is the package. Save the file and run kubectl apply -f in whichever namespace that you want to install this resource manifest. I'll do it in the default namespace. Okay. But you also have to verify if this is in the healthy state. If this is not in the healthy state, that is provider, then your Crossplane will find it difficult to make API call to the cloud provider. How do you verify? kubectl get providers. Completely Kubernetes native. You can see here, it says the health status as false. Let's try to understand what went wrong. Maybe we have installed an old version of it. We will see that kubectl describe provider followed by name of our provider. There is no problem with the deployment. Let's try to see again kubectl get providers. Okay, now it says the health status is true. Probably it took 2 minutes of time. That's totally fine. Now let's create the AWS secrets file. So we will create a Kubernetes secret for it so that our secrets are sensitive and they are protected. So how do we do that? We can create a plain text file, aws-credentials.text.example, something like this. Make sure you have it on your local machine, or you can use something like Vault to make it secure. Paste your credentials here in this format. Update your AWS credentials and save the file. Perfect. Now just run the kubectl command to create this secret. So kubectl create secret. We will create a generic secret and followed by the name of the file. In my case, AWS credentials.text.example. Cool. Now we have the secret created. We have the provider created. There is one step, final step, the provider configuration. A simple YAML manifest again. So I'll call this as provider-config.yaml. And here I'll paste this. So kind is provider configuration, metadata, default. I'm saying this is a secret. And if you want to provide region or any other information, you can do that as well. Let's save this file as well and run kubectl apply-f provider config. Perfect. Now our setup is ready. So one more time, what did we do? We created the provider, then we created the secret, and finally we created the provider configuration. Now you are ready with Crossplane. Whatever resource that you want to create, you can go ahead and create. For example, you want to create S3 bucket, just create a manifest for S3. You can call it s3 bucket.yaml, right? And go to the Crossplane documentation, which I have already done for you. You don't have to go to Crossplane documentation for this example. Create a manifest like this. Kind is bucket, metadata, annotation if you want to provide any annotations, right? And then the region in which you want to create the bucket, the tags on the bucket, probably if you want to say version enabled or encryption enabled, you can provide all that information within the spec. If you go to Crossplane documentation, you will find all of this information. Just like when you create a resource with Terraform, you go to Terraform documentation. Perfect. Let's change the name of the bucket. So I'll change this one here from Crossplane demo bucket 12345 to -Veeramalla. So it clearly says here, this is the actual name of the bucket in AWS. Let's save this and kubectl apply -f s3 bucket.yaml. There you go. As expected, we can see the bucket Crossplane demo bucket 12345 -Veeramalla. And if we look at the metadata or properties, exactly what we needed. Just the tags information, nothing else. So we haven't provided anything like bucket versioning or other things, right? So the bucket versioning is also disabled. Now what we will do, we will go ahead and try to change the tags information, right? If you look at this manifest, here we have provided tags, name Crossplane demo, environment demo, and managed by Crossplane. Let's try to update the environment from demo to production. And let's see if Crossplane identifies it and corrects the information. So these are the user defined tags. let's edit one of them, like the demo one. Click on the edit option from demo to production. Perfect. I've saved this information. Now let's refresh and verify one more time, like if the information is saved. Environment is back to demo, right? So we are updating the configuration. Let me do it again for you. I'll change this time from demo to staging. I'm refreshing it one more time. And there you go. Environment is back to demo. Perfect. So this is how Crossplane implements automatic drift detection without worrying about the stateful management. Now let's come to the actual point. Terraform versus Crossplane. We already discussed about pros and cons of Terraform. We discussed about pros of Crossplane. We talked about its advantages. Now let's talk about its disadvantages. One of the major challenge with Crossplane is Kubernetes itself. I mean, you have to use a Kubernetes cluster or you have to go with a Kubernetes controller to manage your infrastructure. Now, Kubernetes is already complex. You have hundreds of controllers running on your Kubernetes cluster. Now we are dealing with one more controller. And this controller is not an easy one. It comes with a lot of custom resource definitions. It comes with a lot of documentation that you have to follow. It comes with a lot of providers, which are again controllers on your Kubernetes cluster. Even your RBAC, everything should be managed on a Kubernetes cluster. So it becomes a Kubernetes niche skill. Only if you're very, very comfortable with Kubernetes and if you want everything to be in one place. That is, if you want to use Kubernetes as your control plane for everything, then Crossplane is something that you can go with. But another disadvantage is that Crossplane community is not as active as Terraform. Terraform has built this infrastructure community for years of time. So if you are running into any issues, you can look at internet, you can look at the online platforms like ChatGPT, and you can immediately get the correct response from it. But when you look at Crossplane, because the community is growing, you still find inaccurate information. Even sometimes the documentation does not reflect the correct information. So this can be another challenge if you go with Crossplane. Overall, in 2026, I would recommend Terraform. Terraform, stateful management and drift detection can be addressed. In one of our previous videos, I showed you how I built a Terraform drift detector and how it can be extended to auto remediation as well. So my recommendation is go with Terraform. Maybe Crossplane or other projects are good to watch. Maybe you can adopt them in the future. Right now, Terraform is the best solution. Now, I'm saying this without any bias. In fact, I am one of the early adopters of Crossplane. You can find the video of Crossplane on our channel in 2023, where I even made a demo of Crossplane. So in future, if Crossplane does well and if they can do better than Terraform, obviously I'll make a complete deep dive video of Crossplane and I would recommend Crossplane on this channel. Till then, it's Terraform. I hope you found this video insightful. Thank you so much for watching. If you have any questions, do let me know in the comment section. Take care.